Welcome to structural dynamics class. So in this class we will discuss about how to generate elastic designs response spectrum. So this design response spectrum is quite a useful concept in the application of structural dynamics knowledge to earthquake engineering or earthquake resistant design of buildings. So quite often we need the maximum response which a structure will undergo under the action of earthquake. So we can read this design spectrum by using natural period of the building. So when we calculate natural period of the building, either from fundamental analysis or classical analysis or from empirical expression given in the relevant codes, we take that natural period of the building and read the design spectrum values. So these design spectrum values can be either displacement or velocity or acceleration depending on the application. But how do we develop this design spectrum? We have studied the response spectrum. So I suggest students to refer to response spectrum class once and then again come to this design spectrum class. So we'll discuss the steps for generating elastic response spectrum and then design spectrum. So the objective is this will be used for the design of new structures. It is required for seismic safety of existing buildings. So the given plot is the design response spectrum of given in IS 1893 code. So it is given for three types of soil conditions for 5% of damping, and natural period is ranging from 0 seconds to 4 seconds. So how do we select the ground motion? Depending on magnitude of earthquake, distance from the site, fault mechanism, geology and the path. So all these things affect our design spectrum, and local soil conditions. So first step in generating the design response spectrum, that is selection of n number of ground motions. So many ground motions we select and then normalize all the ground motions. That means what time history of that for a given PGA. So say 1 PGA, normalize it to 1 PGA, normalize it to say 0.5 PGA, so 0.5 G P ground acceleration or 1 G P ground acceleration. And then later find response spectrum. So response spectrum values can be spectral displacement, pseudo spectral velocity or pseudo spectral acceleration for each ground motion by any suitable numerical method. So we can use say Newmark's method or we can use central difference method and then natural period for this one on the x-axis can be range from 0.03 seconds up to 50 seconds. So long natural period is there. And then step 4. In step 4, get the statistical mean and mean plus 1 standard deviation spectrum. Then linearization of mean spectrum or mean plus 1 standard deviation by considering peak acceleration, peak velocity and peak displacement depending on the type of the curve we are using. And division according to the period. So Newmark and Hall have suggested certain periods where we can draw the straight lines in between those periods. So as you can see, 1 by 33 seconds is one period, and then 1 by 8 seconds, 10 seconds and 33 seconds. So these are the we can call it as the control points. Then 7, use transformation equation. So that is what, how do we get pseudo spectral velocity from pseudo spectral acceleration and natural period? So when we have pseudo spectral acceleration and corresponding period, so we can use that, plug in those values and get pseudo spectral velocity. So it can also be converted from pseudo spectral displacement. So spectral displacement to spectral velocity conversion formula. Step 8, selection of amplification values based on damping. So that is alpha, A, B and C. So these three values are there available. So acceleration, velocity and displacement. So this is mean values, this is mean plus 1 sigma values. So these are suggested by Newmark and Hall. So amplification of linearized graph. So as you can see this one. So this is the linearized graph, the dotted one, and then amplification of that is taken place and transform back to normal scale. So first we will work it on the log scale and then we will convert that into linear scale. Let us develop one using an example problem. So generation of elastic response spectrum of a given say 10 ground motions. So first normalize ground motions. as you can see here. So this is normalized to 1 g value. So 90 seconds acceleration is given. So all the acceleration values are normalized to this value. They are normalized in the acceleration amplitude, not on time. So the response spectrum SD, PSV and PSA for each ground motion. As you can see, this is acceleration response spectrum, velocity response spectrum and displacement response spectrum. Okay. So the mean at this point will be taken as all these values average. So that is mean at that point. So like that, at all points we take mean. So this is mean response spectrum and then mean plus 1 standard deviation response spectrum. So both are there here now. So mean plus SD, mean PSA, pseudo spectral acceleration spectrum, and again similarly velocity spectrum and then displacement spectrum. So this blue line is telling mean plus 1 standard deviation, green line is telling us mean spectrum. So linearization is done. So linearization, according to using this peak values, we do linearization of this acceleration, velocity and displacement region. So peak ground displacement, peak ground acceleration and peak ground velocity. So this is velocity, this is displacement, this is acceleration. So this is a linearized spectrum. And then now we use the control points of time, and then amplification curve will develop or draw on this one using the amplification coefficients given in Newmark and Hall. So this we need to draw carefully. So this one is amplified using alpha and then parallel line is drawn here. So then we hit here and we hit here. So from this point, from this line, we can directly take this line, a linear line from here to here, and then like that displacement. So it comes here, displacement. So acceleration and displacement and velocity curve is drawn directly from there. And then that curve you convert that into linear scale. So earlier one, it is in the log scale. As you can observe here, this is log on the x-axis and log on y-axis. So this we convert into linear scale. So we get this as elastic design response spectrum. So this we use for all our applications. So this is given for acceleration. We use this for all our structural engineering, earthquake engineering design applications. So what we have studied in this class is the procedure of construction of design response spectrum, okay, or design spectrum. So for that we need a suite of ground motions. So for each ground motion, first we do a normalization of PGA for a given PGA, and then after that we find response spectrum, velocity spectrum and displacement spectra for all these 10 whatever number ground motions, and then we take mean spectrum and mean plus 1 standard deviation spectrum, and then later we find out peak values in that and do the linearization of that, and by using the amplification coefficient values suggested by Newmark and Hall, we amplify this linear spectrum, and then finally we convert that linear spectrum which is on the log scale into natural scale. So that's how we get the design spectrum.